Okay. Let me start. Thank you for joining this Capella webinar. As usually, we have quite a lot of participants today. So if that's the case, I would like to kindly ask you to mute your microphone during the presentation. And as during previous webinar, we will answer some questions at the end of the presentation. So if you want to ask a question, please type it in the dedicated window, and that will summarize all of them after the presentation is finished. Now, I have the pleasure to introduce our speakers. Stefan is well known to regulars. He's working for Thales, where he's in charge of corporate MBSE coaching. He gathers 10 years of experiences on helping operational projects to deploy Capella with success. And he's also acting as a design authority for Capella since its creation and leads most of the development of the tool. Benoit is working for Artal, where he's in charge of the system engineering unit, and he leads the development of the Cypress workbench and has regular Capella-related activities in several years. Those two gentlemen will present you how to deal with model reuse in Capella. The first part will be presented by Stefan, and it will focus on the Capella replicable element technology, also known as REC-RPL. And a second part, presented by Benoit, will address Yuzu, a dedicated add-on for asset management. So thank you both for accepting to make this presentation. And now I will hand over you. Okay, Stefan, you should have the presenter right.
Okay. You see my screen?
Yes.
Okay. Hello, everyone. Thank you for joining. So, as Samuel has introduced, Benoit and I are going to talk about the strategies and tools for model reuse with Capella. There will be basically two different sections. The first one explaining the replicable element, rational and mechanisms, and the second one focusing on libraries and asset management by Benoit. So, model reuse is a vast topic. So I think it's necessary for me to precise what the scope of the webinar is going to be. And the topic that we're going to address is flexible workflows when designing an architecture, and capitalization of parts of models, or even complete models. What we're not going to talk about is variability management and project line engineering. We have solutions for that. It is meant to support model reuse, but it is not the topic of today. So first of all, before diving into the replicable element mechanism, I'm going to explain what were the challenges that we had to face. So the first of these two challenges is building a system architecture model. And in general, we struggle with managing several occurrences of one given element. This is commonly known as types and instances, and I'm going to explain a little bit why this is not as simple as just types and instances. Systems engineers, when they design their system, mainly think in terms of instances. They need to distinguish between the functions that are executed in each computing unit, for example. They want to associate different functional properties to the different instances of the functions, and they want to distinguish the functional chains that go through one or the other of these functions. For example, the scheme is illustrating a redundancy scheme And it is important to know that the blue functional chain is going through the computation unit 1, and the red functional chain through computation unit 2. So we really need to distinguish the instances. Sometimes the second occurrence or the second instance is created after the first one has been created. And sometimes the reusable piece of model is anticipated and used twice. So we need several, there is a need for flexible modeling workflows between usages and definitions. We need flexibility. So I'm going to illustrate this with two very basic use cases. On the right side, I am designing my model, the actual instance of my model, and on the left side, I have the definition. I'm starting to create one component, two components, adding functions to these components, and then I realize that I need a second occurrence of FC2. So what I need is to say, okay, this is going to be something that I am going to reuse. I want to make a definition out of it, and I want to reuse it in my target model. And this is a kind of opportunistic reuse, and this is the way a lot of systems engineers are proceeding. The other way is, okay, we start again doing an architecture model, but we also have something where we work on the different building blocks of our model. So in the definition space, we're going to create a component, allocate functions, define that this is something that is going to be reused, and we instantiate it in another component. We instantiate it twice. So here again, we have a dichotomy between definition and usage, and this big LC2 component is now a definition for a usage in the actual model. So the workflow is really different. And in the life cycle of a model creation, these two workflows have to be supported by the tooling. So this was really the challenge that we tried to cover. The most common way to address this challenge, to deal with definition and usage, is usually to rely on the paradigm of types, parts, and instances. This is what CSML v1, for example, is doing. Our return of experience is that this is not flexible enough. So we've written a paper on this topic. You can go and download it. I'm not going to use the time of the webinar to precisely explain why or what are the problems we faced. But I just want to note that this topic of usage-based modeling is actually a big topic of the CSML v2 specification working group. I just want to note that the type part paradigm is actually an option in Capella, but it is not active by default. When you open Capella and you start working with Capella, the default mode is you start creating instances. The second big challenge is basically to manage building blocks or definitions and assemble them in target projects. So we want to synchronize, we want to share parts of models between different projects. So this is basically what is illustrated here. We have a set of building blocks or definitions elements, and we want to share them or to assemble them in one given project. So this is mainly what Benoit will talk about in the second part of the webinar. So now that we have elaborated a little bit on the challenges that we were trying to address, now I'm going to explain what is the solution that we have implemented in Capella, and I'm going to demonstrate it. So the technology we're going to talk about today is replicable elements, rec and rep. So the core principles are really simple. On the left side, you have a rec for record or replicable element collection. So it's basically a group of model elements. It can be a component and its functions. It can be several other things. and we have replica on the right side. Between replica and records, we have a compliance relationship. So the replica is compliant with the record. It is a copy of the record. And we have synchronizations between replica and records. The records, or rec, correspond to the definitions. The replica correspond to the usages. So rec and rep are synchronized, and replica comply with the source rec according to different schemes. So we have different kinds of compliance. We can imagine black box, so it's strict identity, constrained reuse. So behind that we have the idea that you can reuse a component and its functions. You can add new functions to the component, but you cannot change the interfaces, so the port of the component. Inheritance will be another kind of compliance where you reuse the content of a record, but you can add everything you want. Or you can also customize your own compliance policy. So the idea is that records and replica are synchronized copies with potential different compliance rules. Not everything is implemented in Capella, as we're going to see in the next slide, but this is basically the core principles of records and replicas. So now a few examples of what records and replicas are. So it can be as simple as one component with its provided and required interfaces. It can be a function and its functional tree, its functional breakdown. It can be two functions and their functional exchanges, their connection. It can be a functional chain and its supporting function. It can be a component and its allocated function. Or it can be even something which would couple a physical description and a logical description. So something that goes across the Arcadia layers. So basically any piece of model element can become a record and then a replica. I said previously that between record and replica we have a synchronization. So there is a validation rule in Capella detecting that a replica is not anymore reflecting the content of its record. So we're going to illustrate that in the demo. And we also have compliance verification. We have compliance verification starting from Capella 1.2. And the only compliance that is currently enforced is the black box. Until Capella 1.1, there was no verification of the compliance. There was only the verification of the synchronization. In the demo that is coming now. The other compliance verification, they are open, they are not implemented today. We're just waiting for operational use cases. We just have the ideas, the concepts, the mechanisms, and it's ready to be implemented, but we just wait for an opportunity. So in the demonstration, I'm going to create a record. I'm going to instantiate it and therefore create a replica. I'm going to update the record, validate the replica, and detect that it is not synchronized anymore. I will propagate the changes. I will prove the live compliance enforcement. And I will talk a little bit about model organization when you mix record and replica in the same model. So demo time. So the demo is with the model of a rover. So the rover is the image you have here on the right. And we have a controller that computes the electrical commands and sends them to the motors that will be connected to the chain thread set. So it's basically we have 2 motors and 2 chain thread sets. And on this diagram here, I have only one, and I know that I need a second occurrence of this set of elements. So what I'm going to do is select everything that I want to duplicate, right-click, rec, creation of a rec, so creation of a record from the selection. And now I have a window that describes me everything that will be included in this record. So I'm going to call that the rover, motor, and chain. And I have several options to include associated elements and so on, so to tune the content of the rec. And I can also specify which name I want to customize when I will instantiate this record. So for example here, I'm just specifying that when I will create a new copy of this set of elements, I want that these elements will be suffixed by a specific record, and I'm going to instantiate this record. So rec, instantiate a replica from its rec. I go and select my source record. I precise which suffix I want for the elements that will be renamed. So here I know that I want to have this set of elements for the right side of the rover. And I will enforce the compliance on the fly and use just a dedicated setting here. So now I have created a new replica. I can see that in the tree, in the Project Explorer, but I'm going to display in the model the content of this replica. So here, I'm going to add this element and this element. Inside them, I'm going to display the deployed physical components, so the gear and anything here. And then I'm going to display the allocated function in these ones here. Okay. And now what I can do is I can select my original record. Past the layout, so put them in the same place, but I can just move them here. And I now have a dedicated copy of the set of elements. If I try to change these elements, for example, creating a functional exchange between these two functions, I am not going to be able to do it because we've chosen the black box compliance and it's enforced on the fly. But what I can do is this element with the existing model element. So for example, create here a functional exchange that is electrical power. Create a component exchange that is the direct current, and a physical link that is the power cable. So now I've reconnected my replica to the rest of my architecture. When I select an element of this replica, browsing on the semantic browser, I can navigate and see what replica it is part of, and so on. So now I'm just going to make a change to create a new functional exchange between these two functions. So I'm doing some refactoring, and I say that this one is rotation couple, and this one is only rotation speed. So I'm just changing my definition. What I need to do is select the thing, right-click, rec, update rec from the selection. So it takes into account the changes that I've made. I say OK. And here I have a window that describes me the changes compared to the previous version. I just apply. And now if I validate my instance here, my model, I have an error saying that this replica is not up to date compared to its original source. So the quick fix for that is to open the window that will allow me to update the replica. I have nothing to do. I say OK. I get the differences. I apply. And then I get on my replica the same thing that I have on my rec. So it's really pretty simple. So last thing, try and be quick. When you mix record and replica in the same model, you need to have a little bit of discipline and to organize your model so as to make a distinction between what is part of record and what is part of replica. You all have the access to the IFC sample model that is delivered by default with Capella. And you can see there that we did create a specific diagram to illustrate the content of a rec. We created also a specific diagram to illustrate the. And then we have diagrams in which we see different instances, so different replicas connected to the rest of the architecture. And in the model itself, there are packages to isolate what contributes to the definition of the record. So we have implementation, behavior, and rec definition. So it requires a little bit of discipline to organize the model. Okay, I'm almost done. Two things. We've seen that it is pretty easy to instantiate records, but it is often a challenge to manage the assembly or the connections between the replicas. So there's something exists in Capella. You are able to synchronize the relationships or the connections between two replicas, between the connection that exists between their records. So this is available, and this is extremely useful. Something else that is not available, we're looking for funding, would be to merge the content of a record with something that already exists in the model. So basically, in this one, our record is two components, but actually this LC2 component and this LF2 function would be something that already exists in the model. So I want to merge LF2 here with LF9 here, and I want to merge LC2 here with existing LC so that I get this result here. So we have a pretty good idea of how we would do that and so on. And we know that it's going to either for an operational use case or a funding. So now I'm leaving the floor to Benoit for the rest of the presentation. Are you able to?
Yeah. So thank you, Stéphane. So now we have explained how to build building blocks, but we did not focus on where we should store them. And the basic and quick answer is in libraries, because you cannot reuse elements from a project to another project. If you want to reuse an element, it has to be in a library, and only a sub part of elements can be reused. It can be data model, it can be interfaces, it can be property values, and of course the records that Stefan has just mentioned. And we can make a slight difference between these elements because the three first one, the data interface and property value, have direct references and direct link with the library that is currently in the workspace, while, as you might have understood, the rec are the original of the copy of the replica, and so theoretically, you only need the rec in your workspace when you instantiate or when you update your replica. So it's not exactly the same kind of dependencies for the elements in the libraries. But the things to well understand is, yeah, you have to reuse elements through rec. For example, you cannot have a breakdown of function in your library and directly allocate this function in a project where you have your component breakdown and want to do the allocation. If you want to do this, then you have to go through the rec-ret mechanism. And this is true for our project, but also for libraries, meaning that a library can depend on another library and so on. So you could have a very complex dependency tree among libraries and projects. So I will try to illustrate this, a very quick demo on the library basics. So when I create a library, I need to identify the library at the very beginning because the library is not a project. And there is a different icons, and there is a different icon here that allow you to identify clearly the library. And there you have all the engineering layer of a traditional Capella model. So you could have here add an exchange item, for example. And then when you want to use a library, you have to reference the library at the project level in this menu, libraries, and you manage the references. So here, basically, you have all the libraries that are imported in your workspace. So there is currently only one. So I want to reference this library. And among the different options, I can also decide if I just want to use the library and do not modify anything in the library, or if I'm also allowed to write into the library. We will see later where it could be useful. And so here in my project, I have my library in the dependencies, and if I define a functional breakdown between two functions, I would be able to access all the data that is present in my library here in my model. So that's the very basics of the library. So let's get back to the presentation. So now let's focus on rec and libraries, because as you might have understood, rec and libraries are to be married to achieve most use cases of reuse. And so a good news for next version of Capella 1.2.1 is that there will be an easier way to build a rec from a library, and you only are 2 clicks away from the creation of a rec from a library. So if you have all your library, you do your model in the library, and then choose the rec RPL menu, and you can create the rec from the whole content of the library, meaning that you will have all the engineering layers that you have designed in your Capella model into the rec. And same thing for the update. When you want to change something in your model, you just change the thing in the library and update the world content without going through the selection things that Stefan has demonstrated in the earlier slide. And so with this pattern, we can support the use case that Stefan has mentioned, where we have one rec per library, and so one building block per library. So we will have potentially many libraries, and the system design is mainly about integrating, assembling these building blocks into a consistent design. Somehow, it could be seen as the opposite way of the top-down system to subsystem pattern. So that's more bottom-up, where you just integrate things, things being all into libraries. So let's now have a look at common issues with libraries. The first one, very important, is the refactoring between projects and libraries, because you don't necessarily think of the reuse at the very beginning of your project. So a typical use case is that you start designing your model in a project, and then after some time, or maybe even at the end, you realize that some elements could have been published in a library so that they could be reused by other projects. And so for this move from the project to the library, there are two options. Either you make your library that you want to host your elements. You use the read and write option that I have just mentioned before, and then you directly drag and drop the element from the project explorer of the project to the library. And that's okay for simple situation, but when it comes to complex dependencies between the element you drag and other things into the model, then it's beginning to be quite difficult. So there is a dedicated view for that kind of thing, the move element view, that allow you to identify all the things you want to move in the left part of the presentation here, and the view provides you with feedback on what is missing for the set of elements to be consistent before to be moved into the library. So you drag and drop into this part, and so in red you have the things that are broke on the consistency, and then you add everything that is related to that, and in the end you can move the thing into the library. So that's the most elaborated solution for this refactoring thing. But still, it's nice, but it's still a prototype. So there might be some improvement in the next version of Capella of this feature. I'm not aware of any plan for the very next version, but maybe for the others. The second issue concerning libraries is the versioning. And the basic thing to know is that the library version that the project actually use is the one in the workspace. So if you have this pattern where you have your project with two activity, and one activity is referencing an exchange item in my library 1, 2, 3, then I should be very careful when doing the library update. And if in the version 2 of the library the data exchange is no longer there, then there could be something missing for the description of the exchange item of the interaction here. So this makes the point of the next part of the presentation, that you need to take good care when managing libraries if you want to keep your model consistent. And the good news is that we have developed an add-on for Capella that helps you manage this kind of features. And as we have seen in the previous slide, with the one rec for one library feature, it's more than likely that the number of libraries will grow as you deploy Capella and as you grow your number of Capella assets. And if you add the version thing, then there is probably a time when you may have consistency issues with all the dependencies between projects and libraries and so on. So Yuzu is there for this very purpose. So that's the operational analysis, the very basic one of Yuzu. What users can do with Yuzu is basically to search for Capella assets, either libraries or projects. Then once you have found your asset, you can retrieve in your workspace. And the symmetric is that you can also publish a new asset or a new version of assets. And you also can check to know if there is any update of the asset that you have in your workspace. And also a very important feature is the resolution of all the dependencies. When you have a project that depends on the library, the asset manager Yuzu will determine which library you need and which version and will retrieve it for you. So here is a quick demo. So the very first one is something that maybe some of you have already encountered. So I check out my project from Git. So here I have now my project. I'm happy. I'm trying to contribute to that project. And when I try to open the project, Capella is telling me that something is missing. And actually, there is a library, a basic Capella library that is missing. So the good thing is that I have managed this project with Yuzu. So there is a manifest that describes my project and my dependencies. Yuzu is telling me the same thing, that there is something missing. And when I open the manifest, I see that there is this Capella library, and it is used in version 1.4.0. And so I can just import the library and from the asset manager, and so now it is in my workspace. And now I am allowed to open the project. So that's one basic thing that Yuzu can support. The other thing we'll try to show in a full scenario that sum up also some things from what Stefan has talked in the previous version of the slide. So if I go into my second Capella, so I play another character. I'm in charge of the rover chassis that Stefan has mentioned before. So it's there. Here is my chassis, and just to demonstrate the creation of the rec in 2 clicks. So I get here with the whole library. This is my chassis. The chassis. And so it's there. And that's my rec. And by the way, it has multiple layers of engineering. So that's a full model of the chassis, including the operational system logical view. And once I'm there, I'm done with my job, and I want to publish this so that other people can use this library. So I want to configure this library as a Capella asset. And so a manifest is automatically created here. And in the manifest, all the Capella information is automatically captured. So this is a library. It's been designed with Capella 1.2.1, and these are some metrics of the library. And from there, I can publish the library in my repository, and it's there. And if I play another role, now I am someone that wants to use this library to build my rover. The first thing will be to search for the asset. So here I have a view where I could make queries with the name, the version, the date, whatsoever. So I know that this is the one that I have just created. So I want to import this into my workspace. So I just double click on the thing. So here is my chassis building block. And now I can create my project. So that would be my rover. And as I have already described, I will reference the chassis block in my project so that I could use instantiate the replica in my project. So this is my empty project at the beginning. I can instantiate the chassis from the library. So here it is. Now I have the instance of my replica of the chassis is there. So I can show it just here. I add everything. So it's there. Right. And during this time, the first guy in charge of the chassis could make some change to the rack. So basically, you could add some very tiny thing like an exchange item. We will try to describe the speed, for example, an exchange. Let's say this one, and here we will describe the exchange item for this component exchange. And then the nice thing about the one rack, one lib is that I just need to update. Oops. I can update directly the rack in one click. And so the rack now is updated. And the next thing to do is to publish this asset into the asset manager. So I first need to change the version. And then I can publish it in the asset manager. And on the other side, I may want to be aware that there is a new asset available for this. So first thing will be to also manage my rover project as an asset. And so when I open the manifest, I see that I have this dependencies, this dependency with the library here. And here I can check if there is any update. And so I see that yes, there is a new version available for the library. And so I could try to update to this version. And so the version will be automatically downloaded from the asset manager, and we'll replace the chassis block that is here into 1.0. Right. So I think we're good with the demo part of everything about Yuzu, almost everything. So we have the search and retrieve feature. We can check for dates. We can publish. So that's basically the same thing in slides. So I will pass over these elements. And so we have focused on only Capella assets, Capella libraries, Capella projects. But you could also capture any type of asset with Yuzu, which support the OMG standard for the description of asset packaging. So there is we have created a specific profile for Capella projects and libraries, but you could have your own profile for describing your own type of assets. And with this profile, you can also capture the dependencies between not only Capella projects and Capella libraries, but also Capella project and, for example, tool chains that are needed to produce things starting from Capella. Or you could have assets for document templates with M2Doc or the document itself, or the output generated with the tool chain that I just mentioned. So with Yuzu, you can manage all these kind of dependencies with your Capella project and library. And the last thing is that Yuzu, when you have enter all this information about the assets, of course, all the basic meta information, version, date, whatsoever, but also the Capella version used, and you could build very nice dashboards of your set of projects and libraries, and you could have a very nice representation of how the project is evolving in the different versions. For example, this is the number of elements in the physical architecture for one project into the different versions or whatsoever, and you could reuse this dashboard in web pages. So that's another example of a very nice dashboard. So that's it. You could find more information on Yuzu on our Capella website, which describes some videos and some nice features about Yuzu. Stefan, I think that. Yeah.
Thank you, Benoit. To visualize, finalize this webinar, just one slide on the 14 improvements on Capella itself, because there are many ways we could optimize the ergonomics of record and replica and libraries. So basically, there would be a quick drag and drop on diagram where you could just drop a replica and get all these elements displayed in a diagram. Right now, you have to select manually all elements that you want to display. We would like to have visualization on diagrams. So basically, when you have an architecture model and you are in your semantic browser, you can locate a replica, do right-click, and see a highlight of all the elements that belong to this replica in the current diagram. We would like a simple add to rec from an element to ease the update of the record. We need to have easier project library content refactoring. So seeing that we have a move element view, but there are ways to go further, even though I don't believe that we'll be able to do anything in 2018. And we would also like to have easier motion of records from project to a library. So this is what we are thinking of. And to go further, just as food for thought, and to mention that this whole topic of model reuse, records, replace, library, assets is actually extremely complex, is that we we have a whole new level of challenge when we start thinking about the compositions of different records. So record that contain record, that contain records, and so on. As you have had an idea, as I gave a quick overview, model organization can also be pretty challenging. So for example, in the physical architecture, when you want to describe both the building blocks and the assemblies of the building blocks, and even when you want to model different deployments, so you need several instances of all objects, and you really need a strong organization. And we could also work more with the articulation with model patterns that exist also in Capella. We need advanced assembly between replica. So I've talked a little bit about reconnecting replicas, but basically when you have two components coming from different libraries and so on, you want to have some assistance for creating the connections between these components, even if they don't come from records or replays. When we talk about building blocks, we also sometimes need to have abstracted visions of these building blocks. So for example, you might have a library that describes exhaustively what the content of a building block, but maybe in your architecture you want to use a simplified version, like you want to only know the major functions, all the ports and so on. So you need to have a simplified view of your building block, and that is quite a challenge. And of course, as I mentioned in the beginning, model reuse, when we talk about model reuse, we also think about product line engineering and the articulation between building blocks, variability in building blocks, assembly of building blocks, and variability in the architecture models that is provided by the coupling with product line engineering tools, such as pure variants, is quite a challenge. So as you see, there's a lot of food for thought. So thank you for, Benoit, yeah, thank you for attending this webinar. You have all the links here with videos on Arcadia, Capella, the YouTube channel, the public forum, the website, and the LinkedIn discussion group. And now I leave the floor to Samuel.
Okay, thank you, Stefan. Thank you, Benoit. Now it's time for questions. I've gathered them. The first one is, can we share a rec between models, or is it only showable inside a given model?
So can you repeat?
Can we share a rec between models?
Yes, if we use a library.
Okay. Okay, the second question was, okay, can you create a library from a project or a project from the library and vice versa?
So basically it's changing the status of a project and making it a library, or vice versa.
Yes.
I guess. It is possible to change the nature of a Capella project and make it a library. I think it is in the documentation. It's a little bit touchy. It requires changing one or two things, well, one or two technical aspects, but yes, it is possible.
Yeah, you actually have to tweak two files to change the nature of a project to a library and vice versa.
Okay, thank you. Do you have a timeline for variant management support, PLN, for instance, and based on which tool?
I'm sorry, the sound is, I didn't really hear.
Okay. You have the question on the chat anyway, but do you have a timeline for variant management support?
Wait, I'm trying to see the question because I don't. Do we have a timeline for
variance management?
Variant management?
Yes.
Yeah.
Okay. Yes. A connector between Capella and pure variants is already existing. So we are able to relate feature models with architecture models. It has been presented in the 2 last Capella days. So if you want to know more on this topic, you should contact, well, either us, either contact Pure Variants, because in their, well, Pure Systems, because they have a connector for Capella.
Okay, so is synchronization from replica bidirectional? Can you change property value in replica and update rec? Is this behavior configurable?
It is possible to make a change in, well, if you don't enforce the live compliance, you can change your replica, and you can promote the changes that you had in your replica in the rec. Is it behavior configurable? If the rec, if the record is in the library and you don't have access, like write access on the library, then you won't be able to update your record. So in a way, yes, it is configurable, and yes, it is bidirectional.
Okay, I have no more questions. So this is your last chance if you have a question. Just waiting to see if we have a last one. I will just precise that this presentation is recorded, and we will share it after, so you were able to ask. Okay, it seems we don't have any other questions. Anyway, you are free to ask directly to Stefan and Benoit your question after this webinar. Oh, okay. I have a last one. Is it possible to have a rec across layer?
Yes.
Yes.
Okay, thank you.
And it's pretty easy with 2-click creation from a library.
Okay, thank you. So you may have other questions, but we're running out of time. So don't hesitate to contact us in this case. And as a reminder, okay, you are still a way to keep updated and to find information. Stefan already talked about those different programs, links, and so on. So I would like to thank you all for attending this webinar, and please feel free to contact us if you want to learn more. I wish you all a nice evening. Bye.